Now, in a previous video, I introduced a law that we can use when we're dividing two indices together, and that is linked below. But today, we're going to have a look at using that law when there's unknowns involved. So, let's begin. So let's start by recapping the dividing indices law from our last video. When we're dividing two indices with the same base, we keep the base and we subtract the exponents. For example, here I've got a to the power of m divided by a to the power of n written in fraction form. Now in this case, we're dividing two indices with the same base. Our base is a, so we keep the base and we subtract the exponent. So that's going to be m subtract n. So let's take a look at how we use these with unknowns. Now throughout this video, I'm going to use two methods. The first method is where I'm going to expand each problem and then simplify it, where the second method is the more preferable method I'd like you to use. And that's where we take the index law and we apply it to the problem. So let's start with method 1. Now the problem we've got here is a to the fourth power divided by a to the second power. So when we look to expand this, a to the fourth power is the same as saying a multiplied by itself a total of 4 times, and that's all going to be divided by a multiplied by itself twice. Now when we write it in fractional form, we can see that we can start cancelling down. And we can cancel this a with this a here. But rather than just cross them out, I'm actually going to show you why cancelling works. Now when we've got a divided by a, we've got a number divided by the same number. So it's dividing by itself. So that's equal to 1. But 1 as a fraction is 1 over 1. Now we can apply that same logic with the second a here. So that's going to be 1 over 1. So when we simplify that step on the second line here, it's going to be 1 times a times a all over 1 times 1. Okay, so what is anything times 1? Well, it is what it is. So this is going to be equal to 1 times 1, which will be 1. 1 times a, which is a. So it's going to be equal to a times itself, or a to the second power. And that's going to be divided by 1 times 1, which is 1. Now you'll notice here I've got a to the second power divided by 1. But what is anything divided by 1? It is itself. So this is going to be equal to a to the second power. Alright, so let's take a look at when we use the law. Now the law states that when we're dividing two indices with the same base, we keep the base but subtract the exponents. So in this case, we're dividing two indices with the same base of a. So we keep the base of a and we subtract the exponents. So that's going to be 4 subtract 2, which is equal to a to the second power. Now you'll notice that I've arrived to the same answer here, but in a much more efficient method. So now we've applied that, let's take a look at a bit more of a complex problem. So here in front of me now, I've got coefficients in front of the a. So let's expand and then simplify this problem. Well, when we look to expand it, we can actually break the fraction up with a multiply sign between it. So this is going to be equal to 4 over 2 multiplied by a to the 7th power over a to the 3rd power. Now if we treat this problem in smaller chunks, we know that 4 divided by 2 is equal to 2. And that is going to be multiplied by a multiplied by itself 7 times, all divided by a multiplied by itself 3 times. Now when I look to cancel this problem down, this time I'm not going to include the ones. This will cancel here, it'll cancel here, it'll cancel here. So this problem is equal to 2 multiplied by a times a times a times a, which is equal to 2 times a multiplied by itself 4 times, so to the power of 4. And we find that that is equal to 2a to the power of 4. So what happens when we apply the laws? Well, because the coefficients are multiplying everything on the top and bottom line, we need to do that separately. So this is going to be equal to 4 divided by 2 as its own problem, multiplied by a to the power of 7 take 3. Now as you can see on the left here, because the bases were the same, what I've actually done is kept the base the same but subtracted the exponents. Now when I simplify this down, that is going to be equal to 4 divided by 2, which is 2, multiplied by a to the power of 7 take 3, which is 4. Now once again you can see we've arrived at the same answer, but by using the law we've found a much more efficient method. So let's take a look at one more problem where we've got more than one unknown. Well, when we look to expand and simplify, because there's nothing but multiplication happening again, I can break this problem up. So this is equal to 6 divided by 2 multiplied by a to the power of 5 over a to the power of 2 multiplied by b to the power of 7 over b, which is to the power of 1 if we want to write it there. So our next step, let's expand this right out. So this is equal to 6 over 2 multiplied by a times itself 5 times, all divided by a times itself twice, all multiplied by b times itself 7 times, all divided by b, and now we look to cancel the problem down. So this will cancel, and this one will cancel. So what we've got remaining is 6 divided by 2, which is equal to 3, multiplied by a times itself 3 times, so that's a to the power of 3, multiplied by b times itself 6 times, which is b to the power of 6. And finally, because we're multiplying a number with two unknowns, we can represent this problem as 3 multiplied by a to the power of 3 times b to the power of 6. So let's take a look at what happens when we use the law. Well, this is going to be equal to 6 divided by 2, all multiplied by a to the power of 5 subtract 2, all multiplied by b to the power of 7 subtract 1. Remember, that 1 exists above the b even though we don't write it. Now when we simplify this further, that's going to be equal to 6 divided by 2, which is 3, multiplied by a to the power of 5 subtract 2, which is also 3, multiplied by b to the power of 7 subtract 1, which is 6. So as you can see, we do arrive to the same solution, but when you use the index law for dividing indices, we have a much more efficient method. So now I'd like for you to have a go. In front of me I've got some problems that I'd like you to simplify and leave your answers in index form. I'd like you to use method 2, where you apply the index law, but you can always use method 1 to check your answers.